This video describes the Samsung Cloud Native Computing team's centralized logging solution for a production-grade Kubernetes cluster. Reliably capturing logs from a Kubernetes cluster is challenging for a variety of reasons. The main reason is that containers are ephemeral and may be destroyed or rebuilt and start or stop at any point. So how do you persist the data from applications running inside each container? Another logging concern for a production-grade cluster is making the logs available for quick operational troubleshooting, as well as long-term analytics and reporting. So what does Kubernetes offer out of the box? For very basic log visualization, you can use the kubectl command logs on an individual pod to see the standard out and standard error from the container. But if this pod dies, these logs will go with it. Kubernetes offers a cluster-level logging solution that uses Fluentd and Elasticsearch to capture and store logs. But if you're looking to manage logs from a production-grade Kubernetes cluster, you will probably need more functionality from your logging pipeline. We have been developing a centralized logging solution that ensures logs are reliably pulled from pods by Fluentd, enriched with Kubernetes metadata, passed to Kafka for buffering and monitoring, sent to a central Fluentd processor, which can then forward to any number of storage solutions. We are currently using Elasticsearch and making the logs available on Kibana for visualization. The end-to-end pipeline never leaves the cluster, and here's a breakdown of how we configure and deploy our system. To quickly remove logs from pods, we use a node-level Fluentd aggregator deployed as a daemon set. We enrich the logs with Kubernetes metadata, which saves the details from the origin pod. To keep the requirements for Fluentd lightweight, we immediately pass the logs to Kafka, which decouples the message parsing and message collection. Kafka can be configured to perform any number of business intelligence processes. It also supports multiple consumers of the log streams and acts as a message bus for buffering data. Kafka is deployed as a stateful set and uses Zookeeper for coordination and cluster state. From Kafka, the logs move to a central Fluentd processor. This component can perform more enrichment and also send all or some logs to multiple storage solutions. Currently, our pipeline uses Elasticsearch for queryable storage. Elasticsearch is deployed as a cluster of master pods and data pods that can be easily scaled. At the end of our pipeline, we offer Kibana for data visualization. Kibana offers a great user interface for developers or non-developers to examine the data from your cluster. You can deploy this entire logging solution with a single Helm chart. If you want to test this chart, we recommend using K2, our open source tool for spinning up production-grade Kubernetes clusters. This pipeline is still a work in progress, and we will be expanding its features and stability in the near future. Thanks for watching, and get on GitHub to send us any follow-up questions or comments.